Okay. Hello, folks. How's it going? Let me go to Critter. There we are. Alright, so today, first ever A-level video. First ever A-level tutorial, what to start with. We're going to kind of start from the start, the very start, and make a little bit of a transition from GCSE sort of stuff to A-level sort of stuff, because my plan is to really cover everything on A-level, like everything. And if you were to follow these videos right the way through, then hopefully, if you follow them without kind of getting stuck or trapped on anything, then hopefully it will be quite detailed and you'll cover everything. So that'll be good. So we're going to start off with, we're going to make a little bit of a transition from GCSE to A-level. So we're going to be starting with a bit of algebra, completing the square and applying that to circles, because it's a fairly important kind of topic. So let's just start off with an equation. Let's say if we've got the equation, I don't know, x squared, oh we're still green, oh well, x squared plus y squared plus 4x minus 6y, and let's say that that's equal to something. So if it's equal to something, then it's actually an equation, and since we've got two variables, we can plot that on a graph. I want it to be equal to something where we can actually make a bit of sense to it. So in order for that to happen, it has to be a square number. So those numbers, add that on. Alright, so 12, that'll work. I'm aware 12 is not a square number, but it will be by magic, hopefully, if I've done that correctly. Alright, so what we're going to do with this equation is we're going to find out what it is. First of all, it makes some kind of shape on a graph. What in the world kind of shape is it going to make? That's you can probably guess. It's going to be a circle. The title of the video is circles, I suppose. Alright, so we're going to see how in the world this is going to make a circle. We're going to look at the standard equation for a circle, and what information we can get from that standard equation of a circle. So apparently this makes a circle. Let's see how. The standard equation, the standard format for a circle, we'll come back to this equation in particular. But first, the standard format for the equation of a circle is x minus a squared plus y minus b squared is equal to r squared. So that is the standard equation for a circle. Memorize that immediately. Go. Alright, so the coordinates of the center of that circle, this makes a circle on just a normal graph, you know, with the x that goes across and the y axis, and the four quadrants and all that stuff. This will make a circle on one of those graphs. This is the standard equation for it. Standard format, like how ax squared plus bx plus c, y equals ax squared plus bx plus c is the standard format for a parabola. That kind of standard format. This is the standard format of a circle. The equation of that, this equation for a circle tells us that the center of the circle is these two, AB. Notice that we've got minus signs here, so it's the negative of whatever this number and this number would be. So if this was x plus 10 squared, then the x coordinate for the center of the circle would end up being the negative of plus 10, which is minus 10. If it's a minus, then the x coordinate for the center of the circle would be a positive. So the coordinates for the center of this circle would be AB. So this is the center. It's RE, isn't it? Oh, yeah, I think that's American. Oh well. So that's the center of the circle, AB. We've got minus A minus B. Make sure you make sure that makes sense. And then we've got the radius squared. R stands for radius, so R is radius. Okay, so this is the standard format of the equation of a circle. So an example of this is if we had x plus 3 squared plus, let's say, y minus 2 squared equals 100. Okay, so this is an equation, this is a particular equation of a circle, and for this equation of a circle, this circle on a graph would look something kind of like that, roughly. The center of the circle, the coordinates of the center, is the negative of these two numbers. The negative of positive 3 is just minus 3. The negative of minus 2 is positive 2. So the coordinates of the center of the circle would be minus 3, 2, right about there. So that should be the center. So it should be over there, really, somewhere. And then this r is the radius of the circle. The radius of this circle is, well, this equation equals 100. Apparently that's r squared. If r is the radius, what we've got here, the 100, that's r squared. So let's write that down. 100 equals r squared, because if you actually write down the information that you know to be true, then you can make sense of it a bit more. So get into the habit of writing equations like this down. Don't just think them. I used to just think them. It makes it more difficult if you just think them. Just write it down, because you might have to do calculus on that equation. You might need that particular bit later on. It just makes it easier to see. So get into the habit of writing down any information that you might need, any kind of equation. Right, so 100 equals r squared. What's r going to be? That's straightforward, isn't it? Square root of 100. 10 squared is 100. So the radius of this circle, r, is just 10. Okay. Now then, let's go back to this. This doesn't look anything like that. This looks completely different. 12's not even a square number. What's that going to be? 3 and a bit? Alright, so we need to, first of all, we need to get this into the format, into the standard format for the equation of a circle. So we need it to look like this. X, not plus, minus. X minus a squared plus y minus b squared equals r squared. We need it to look like this. Well, for it to look like that, I mean, we've got x squared. Could that be x plus 0 squared? But then we've got 4x and a minus 6y on their own, which there's no x or y's on their own here. They're all being squared. There's a couple of ways that we could do this. We could multiply these brackets out and see what that looks like. We could then maybe kind of compare it to what we've got up here. Or we can use a kind of almost like a trick, and we can complete the square on this equation. So we need to complete the square. Hopefully, if you've done GCSE and you're kind of moving on to A level, hopefully you'll remember the whole completing the square thing. But that's a fairly important technique for this. So let's have a go at that. Alright, so completing the square. If you don't know what it is, I'll show you what it is. It's alright. And we'll make a little bit of sense of it. Let's put the x's and the y's next to each other. So to do that, I'm literally just going to swap the y squared and the 4x around. So we've got x squared plus 4x, and then plus y squared plus, nope, not plus, minus 6y, and that equals 12, because we haven't changed anything. We literally just swapped those around. You still with me so far? Alright, so now that we've done that, we can complete the square for x. So what that means is we're going to put it into this format. Well, if we complete the square here, we need to put x plus something squared, and that's got to equal x squared plus 4x. Think about what could this number be, where if we multiplied out the brackets we would end up with x squared plus 4x. This is the square. In fact, let's put that over here. So we've got x squared plus 4x. We want to change that to be x plus something squared. So that's the format for completing the square. That's what you do. You change it into a set of brackets with x plus a number, some kind of number, whatever it is, squared. So in order for these brackets to multiply out and give us x squared plus 4x, remember that when you square something, you're just timesing it by itself. So this is going to be x plus something multiplied by x plus something. It's just times by itself. That number is going to be the same thing. If we multiply this out, we would have x times x for x squared. This number times x for something x. Let's call this a. So we've got ax there. And then we'd have this x times this a for another ax. So that would just be 2ax basically, which will be better. So let's write 2ax. So we've got x times x for x squared, and then we've got x times a and a times x for 2ax, and then we've got a times a for a squared. Well, this needs to compare to this. So we've got the x squared, that's alright. The 2ax should represent the 4x. If 2ax is 4x, let's write that out. 2ax is equal to 4x. If we divide both sides by x, we've got 2a equals 4. And then if 2a is 4, a is 2. So if a is 2, that's what will go there. X plus 2 squared. There's an issue with that though. We end up with a squared on the end. That's, if a is 2, a squared is going to be 4, because 2 squared is 4. So this x plus 2 squared doesn't equal x squared plus 4x. It would equal x squared plus 4x plus 2 squared, which is 4. But if we take that 4 away, just kind of on the outside, almost like cheating, not just taking away 4, that is now equal to x squared plus 4x. That's completing the square. This is the squared, this is the square, x plus 2, because it's squared, so that's the square. That completes the square. Okay, so that's why it's called completing the square. Alright, so we've got x plus 2 squared minus 4. Remember that, we need to bring that over here. X plus 2 squared minus 4. X plus 2 squared minus 4. Alright, that's this bit. We can replace that with x plus 2 squared minus 4. That's just there. There. X plus 2 squared minus 4. And then plus y squared minus 6y. We can do the exact same thing to y squared minus 6y. We can put it in brackets. We can have y plus or minus. There's a little hint there, it's going to be a minus because it's minus 6y. It's going to be squared, and then we'll have to complete the square. Alright, so if we were to multiply these brackets out, it would need to equal y squared minus 6y. Well, we've got y times y for y squared. Y will multiply with this number twice, and they'll add together to make minus 6y. So that must be minus 3. Little tip, it's always half of this number, and then divided by like the square root of the coefficient of y squared or something like that. But it's always half of that number. If it's just y squared or just x squared, not 4y squared or something like that, then it's just going to be half of that number. Alright, so like in this one, it was 4x there. 4x, and half of 4 is 2, so we had x plus 2 squared. But if we multiply out y minus 3 squared, if we have that in brackets and we multiply out the brackets, we end up with minus 3 times minus 3, which is a positive 9. We don't want a positive 9 because it's not y squared minus 6y plus 9. There is no 9. So we need to take the 9 away. The 9 that we get from multiplying out these brackets. That completes the square. This is the square. This completes the square. Alright, so now we've got these two things. X plus 2 squared minus 4 plus y minus 3 squared minus 9 equals 12. The other side. It's just 12. Alright. Let's tidy this up a little bit. This minus 4 and this minus 9. Let's put those over here. If we add 4 and 9 to both sides. So we've got x plus 2 squared x plus 2 squared, and we've got y minus 3 squared. That was positive, plus sign over there. Y minus 3 squared. And then the minus 4 and the minus 9, we're going to add those to the 12. So those will equal 12 plus 4 plus 9. 12 plus 4 plus 9 is 25. So we've got x plus 2 squared plus y minus... Oh! Can I change the colour back? Nope. Oh well, we're stuck with a light green now. Ah, we can't see that. Go back to dark green. Slightly different shade, but it'll be alright. Y minus 3 squared equals 25. 12 plus 4 plus 9, 25. There we are. Let's make it a slightly darker shade. Hello. That kind of matches it. I'm happy with that. Alright. Now then, x plus 2 squared plus y minus 3 squared equals 25. That is in the format for the standard equation of a circle. That's the standard format. So that's like x minus a squared plus y minus b squared equals r squared. That's the equation. The radius would be, well, this is r squared, 25. R squared is the 25 bit. So the radius is the square root of 25. 5 5s are 25, so the square root of 25 is 5. The coordinates of the centre of the circle is the negative of these two numbers in the bracket here. So negative of plus 2 is minus 2. Minus 2. The negative of minus 3 is, well, you could just think of those two numbers times minus 1. Minus 3 times minus 1 is 3. So the coordinates for the centre of the circle is minus 2, 3. So if we had that on a graph, we'd have minus 2 there, and then 3 up there. That's the centre. The radius is 5, so it would be a circle all the way around that centre. Something like that. We could then find out more information about what's the area, pi r squared. What's the circumference, 2 pi r. 31.41592653589793238462643, etc. Alright, so let's practice that. We'll do a few of those. Don't worry if you got stuck or lost, or you're just like, nah, I'm not doing A-level maths anymore. That's ridiculous. It looks ridiculous for the first time you do it, but you'll get to a point where you'll watch this video back and think, oh god, this is so easy. It looks rock hard, but it's dead easy. It just takes a little bit of practice. Don't be put off by the first one. Alright, so let's do the exact same thing again. Not the exact same thing. You could just put the video to the start and watch it again. We'll do another example. Let's say if we've got x squared and y squared, and we've also got, let's have one that makes a horrible number. 5x. That's not a 5. 5x. Thank you, hand. Plus 11y, because why not? And let's say that that is equal to 80. 80. Yeah, why not? Alright, so we haven't actually got a question. There wasn't even a question in the last one. It was just looking at an equation and doing stuff at it. Like that's all it was really. We didn't answer any questions. So far we've answered 0 questions. So let's put a question on this. The question is, find the coordinates of the centre of the circle and find the radius of this circle. If it was an exam question, it would look something like the following equation. The following is the equation of a circle C, and it would name the circle or something like that. And then it would give you the equation, and it would say, part A, find the coordinates of the centre of the circle C. And then part B, find the radius of circle C. Something like that. So let's say we've got those 2 questions. We want the coordinates of the centre of the circle, this circle. This is the equation of the circle. And we want the radius of the circle. So it's not in a very nice format for us to find the coordinates of the centre of the circle or the radius of the circle. But we can change that by completing the square. So first of all, let's put the x's together and the y's together. So if we say x squared plus 5x plus, and then the y's, so y squared plus 11y equals 80. Alright, now we need to complete the square. So we've got x squared and 5x. We want to put it in the format of x plus, because that's a plus, something squared. Now when we multiply this out, it has to make x squared plus 5x. In order for it to make 5x, we need half of 5 in here, because it will multiply with the x twice and then add together to make 5x. So half of 5 is 2.5. Oh yay, decimals. 2.5. So we've got x plus 2.5 squared. If we multiply these out, we'll end up with x times x for x squared, x times 2.5 for 2.5x, 2.5 times x for another 2.5x. That makes the x squared and the 5x. But we also end up with 2.5 times 2.5, which is 6.25. We don't want that. There's no plus 6.25 here. So we need to take away the 6.25 that we don't want. Now we've got our square and we've completed it with the minus 6.25. Similarly, for y squared plus 11y, we need to do y plus something squared. That something is going to be half of 11 for the same reason that this was half of the 5. So half of 11 is 5.5. When we multiply these out, we get y times y for y squared, y times 5.5, and 5.5 times y for a total of 11y. And we'll also get 5.5 times 5.5 for 30.25, which we don't want. So we need to take away the 30.25 as well. And then that completes this square. Now all of that is the same as x squared plus 5x plus y squared plus 11y, which is the same as 80. It says here equals 80. So we can say that all of this equals 80. We can, in another way of saying that is we can substitute this expression in the box in the place of this expression in the other box. So we can swap those around. Those are interchangeable expressions because they're the same as each other. They're identical expressions. Alright, now then, let's put horrible numbers, 6.25 and 30.25. Let's put those to the other side. So if we're doing that, we need to add 6.25 and 30.25 onto 80. And then that will leave us with x plus 2.5 on the left, squared, plus y plus 5.5 squared. So that will equal 80 plus minus 30.25, but we're adding that on, so plus 30.25, because minus 30.25 plus 30.25 gets rid of it. We want rid of it on the left, so we add it on, plus 6.25 because we want rid of that one as well. There we are. Alright, now we can kind of see what the center of the circle is going to be, because we've got this side in the right format, and on the right we're just going to have some number. So the center of the circle is going to be minus 2.5, minus 5.5, because it's already minus a minus b, where minus a is 2.5, so a is the negative of that, which is minus 2.5. So the coordinates of the center of the circle are minus 2.5 minus 5.5. That's the coordinates of the center of this circle. Alright. Wonderful. If we want the radius, this number that it equals is r squared. Remember, the standard equation of a circle is x, nope, not x plus, x minus a squared plus y minus b squared is equal to r squared. That's the standard equation for a circle. If you're watching this live and you're stuck or you don't understand anything as well, I am checking the comments. I probably should have said that like half an hour ago, but I'm flipping. When you hear me do this, I'm flipping backwards and forwards from Facebook to Critter to draw on, so I'm checking the comments. So if you want to ask something, feel free to ask. Alright, so the standard equation for a circle is this, and it equals r squared. It always equals r squared. In this case, it equals all of this. So all of this is r squared. So 80 plus 30.25 plus 6.25, which is 116.5, is r squared. That's the radius squared. So the radius is like 10.5 or something, 10.8-ish. Extraordinarily close to 10.8, 10.7 something, I think. Or 10.8 something. But yeah, the radius r is roughly 10.8-ish. So now we know the radius. Roughly 10.8. Wiggly equals sign for roughly. It's approximately roughly something like 10.8. Okay, so yeah, completing the square, really important little trick, especially for circles. So it's not just for finding the vertex of a graph, the vertex of a parabola, which you can use it for that when you find the minimum point or the maximum point if it's upside down of one of those quadratic equation thingies. There's easier ways to do that than completing the square. So when you learn those easier ways, it's kind of like completing the square was pointless. But then completing the square is really important for this. So it turns out you do need it. Yeah, it's often on exams where it'll ask you to complete the square anyway. Alright. Jesus, we're not even halfway through. Alright, let's practice that a bit more. Let's practice just completing the square, because that can get tricky. If we had an equation for a circle and it was something weird, like if it didn't have x squared but it had 3x squared or something like that, that transforms it. That would change the look of the circle into an ellipse, which is like an oval. But you don't need to know about that. It's just a fun fact. But you don't need to know about that for the A level, but you do need to be able to complete the square nevertheless with exotic coefficients of the highest degree variable. Alright, so let's say we've got something strange like 9x squared. Let's say there's a parabola and it's 9x squared. Oh, some terms, that's something that we'll go over soon. But anyway, let's say that there's a quadratic equation which is 9x squared plus 3x, nah, not 3, that's horrifying, plus 36x plus 10. Y equals 9x squared plus 36x plus 10. Something familiar, thank God. A quadratic equation. Yes, we know this. Complete the square. Go! Alright, so this is a bit worse than the last ones, even though there's only just y at the start, not y squared and something y. This is possibly a bit trickier, but you should be able to, if you followed the rest of this video at the start of it, you should be able to suss this out on your own. Just think of the format of completing the square. It needs to be in the format of something with a square and then a number on the end. The start of it is going to multiply by itself. When we multiply out these brackets, it's got to make this. That number on the end doesn't matter. It's got to make this. So what's going to go in the brackets? Well, this bit is going to multiply by itself to make 9x squared. So what multiplies by itself to make 9x squared? That would be the square root of 9 and then the square root of x squared. The square root of 9 is 3 and the square root of x squared is just x. So this bit's just going to be 3x. So when we multiply out those brackets, we'll end up with 3x times 3x for 9x squared. This bit isn't as straightforward as just half of that number anymore, because we have to be a little bit careful, because when we multiply out these brackets, we've got 3x times whatever this number is, and then whatever this number is times 3x again. So we can't just put half of 36 in, because if we put 18 there and we end up with 54x there and then another 54x there, So we'll end up with 108x. If we just half that number and shove it there, we don't get 36x, we get 108x, which is wrong because we want 36x. So what we need to do is we need to let's just put a in it and solve for a. Let's say that's a. We'll multiply out the brackets and see what we get. All right. So 3x times 3x, 9x squared. Marvelous. That's what we want. Don't have to worry about that. 3x times a, 3ax. A times 3x, that's another 3ax. And then a times a squared. Alright, 3ax and 3ax is 6ax. So we've got 9x squared plus 6ax plus a squared. That's got to be the same as this. The 9x squared bit's right, but the 36x, we've got 6ax. So we can figure out what a is by dividing 36 by 6. Basically, that was a bit quick, but if we compare the coefficients, we can say that since this is the bit with x in it, not x squared, but just x, not a number on its own, it's got x in it, like this bit does, 36x, that's just got x in it, not x squared, not a number on its own, just x. That means that the 6ax has to equal the 36x. So if we put that over here, 6ax is equal to the 36x. If we divide both sides by the x, they can cancel out. So we get 6a equals 36. And then if we divide both sides by 6, we get a equals 6. So this number is just 6. We could multiply them out and we could see what we'll get, and we should end up with 9x squared plus 36x, but we wouldn't get plus 10 on the end. We would get a squared, we would get 6 squared, and 6 squared is 36. We don't want 36, we wanted 10. So if we take away the 36 and then we can add 10 on, that will make this exactly the same as this. So taking away 36 and then adding 10, we could just take away 26. That would change the 36 into a 10. Okay. It's a bit tricky. It is a bit tricky. It is a bit complicated. But, I mean, that's just completing the square. It was a topic on the GCSE if you did that. So hopefully you stuck in when you were doing your GCSEs if you're moving on to A level from GCSE. But yeah, that's completing the square. Let's have a look at solving some information about circles. Let's go back to that very, very first one. Alright, so we've got all of this. X squared, y squared, 4x minus 6y is equal to 12. So we've got x squared, y squared, 4x minus 6y is equal to 12. Let's see if we can find not just the coordinates of the center of the circle, not just the radius of the circle, but let's see if we can find all of the x and all of the y intercepts. It's a little bit trickier, but let's have a go at that. So first of all, let's kind of have a little bit of a refresh. We'll work through this one again to put it in the standard format for the equation of a circle. So to do that, let's put the x's and the y's together. So we've got x squared and 4x, y squared minus 6y, x squared 4x, there we are, and then the y's, y squared. I know that's a plus, by the way, just because it's plus there. I'm literally just copying the signs. That's a term, that's a term, that's a term, that's a term, and I'm just swapping them around. So y squared minus 6y equals 12. Wonderful. Alright, let's complete the square on the x's. So x plus something squared has to equal x squared plus 4x. So that's going to be x plus 2 squared, because x times 2 and 2 times x will make 4x. But we end up with a plus 4 that we don't want, so we take away 4. And then we've got the y bit. So y minus, because it's a minus there, half of 6 is 3 squared, but we end up with a 9 that we don't want when we multiply out these. -3 times -3 is 9. So we take away that 9. And that will still equal 12. You could even ignore the equal 12's bit, and you could just pick numbers for x and y and see if this makes the same thing. Say if x was 1 and y is 10. We could see what we get if we plug those numbers in. And let's try that because it's quite interesting. 1 squared and 4 ones is 5. 10 squared minus 6 tens is 40. 5 and 40 is 45. So that equals 45 when x is 1 and y is 10. 1 squared, 4 ones, 5. 10 squared minus 6 tens, 40, 45. If we do the same thing for this with the same values, 1 and 10, we should get... Oh, that looks like an I now. We should get 45 again. So x is 1. 1 plus 2 is 3. Squared is 9. Minus 4 is 5. And then y is 10. So 10 minus 3 is 7. Squared is 49. Minus 9 is just 40. That was meant to be a 5, but it didn't look right. And 5 plus 40 is 45. So these are exactly the same. No matter what numbers you pick for x and y, they would always make the same number. Not always 45, but always the same as each other, which is quite interesting. It's just kind of good to see why the bottom expression also equals 12, just because the top one does. Because the bottom one and the top one are exactly the same thing. No matter what they equal, no matter what that top bit equals, the bottom one has to equal it, because they'll always be equal. Alright, now then, let's put the -4 and the -9 on this side. So if we add 4 and 9 together, that makes 13. 12 and 13 is 25. So we've got x plus 2 squared plus y minus 3 squared equals 25. We could write 25, or we could write 5 squared. Doesn't matter, it's the same thing. I'm just writing 5 squared for fun. Alright, this is in the format of x minus a squared plus y minus b squared equals r squared. If we put 5 squared instead of 25, we can see that r is 5. That's why that's kind of worth writing. So we know the coordinates of the centre is AB, where this is minus a, this is minus b. So a is -2, b is +3. So that's the coordinates of the centre, and then r is 5. But what are the intercepts? What in the world are the intercepts? Now, to get the intercepts, the x and the y intercepts, we could use the exact equation that we've got. Excuse me. We could use this exact equation, but there is a slightly easier way. Well, we can use this. Think of a graph. If we want the x-intercepts and the y-intercepts of this circle, that's there, 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 and there. That's those coordinates that we want. And we've already got half of them. And that's as in we've already got either the x or the y component of each coordinate. For this one, we know that y is going to be 0. So this is something 0 because it's on the x-axis. And for this one, y is also going to be 0 because it's on the x-axis. So that's going to be something 0 as well. For this one and this one, x is going to be 0. So those are going to be 0 something. Same for that one. So what we could do is put our value that we know for each one into our equation. If x is 0 for these two, then we can say that x here is 0. So x plus 2, that's going to be 0 plus 2 squared, which is 4. So we can plug that value in to the equation. And personally, I think it's a little bit easier to use this one, this equation. Just because if we put 0 for x into that, that's going to get rid of that and that. Because 0 squared is 0, 4 zeros are 0. So we're just going to be left with this. Y squared minus 6y equals 12. Y squared minus 6y equals 12. Similarly, if we put y equals 0 into this equation, it's going to get rid of this y squared, because 0 squared is 0. It's going to get rid of the minus 6y, because minus 6 times 0 is 0. So we're just going to be left with x squared plus 4x equals 12. X squared plus 4x equals 12. That's just a couple of quadratic equations, and if we solve both of them and get both the answers for each, then that's all 4 of these. So let's do that. So y squared minus 6y equals 12. It's a quadratic equation. We just need to solve it. So let's make it equal 0. Y squared minus 6y minus 12 equals 0. And if we solve that, we could factorize it. We could say, what can we say? Minus, I think it will factorize. Maybe it won't. Nah, it doesn't look like it will. Two numbers that add together to make minus 6, times together to make minus 12. Y plus something, y minus something. No, it doesn't look like it does factorize. Not very nicely anyway. Oh well, let's use the formula. So A is 1, B is minus 6, C is minus 12. So we've got 6 plus or minus the square root of B squared minus 4AC. So that's 36 plus 48. That's why it won't factorize, because that's not a nice square number. All over 2a, which is 2. Oh well, it was unlikely that it was going to factorize, because that was just kind of a random equation that I made up. Alright, so 36 and 48 is 84. So we end up with the square root of 84. So we've got 6. Let's say 2 root 21 instead of... Alright, let me explain this bit. Let me explain this a bit better. So this is 84. So we've got 6 plus or minus the square root of 84 over 2. We can change the 84 to be the square root of 2 products that multiply together to make 84, which we could say is 4 and 21, because 4 times 21 is 84. And when you've got the square root of the product of 2 numbers, that's the same as the square root of each number individually multiplied together. So the square root of 4 times the square root of 21. So this 84, this root 84, is the same as root 4, which is 2. Square root of 4 is 2. So this is the same as 2 times root 21. So this is 6 plus or minus 2 root 21 all over 2. Then we can cancel out this 2 with the 6 and the 2. So we can say that this is 3 plus or minus 2 over 2 is 1 root 21. So we've got 3 plus or minus root 21. And those are the values of y. So that's these two. So this will be 3 plus, let's just draw an arrow. 3 plus root 21. And this will be the negative one, because it's the negative value for y. This is where y is a minus number. So this is 3 minus root 21. Okay. Now then, for x, maybe this one will factorize and it'll be a bit nicer. Yes, it will. Wonderful. For x, I won't factorize it straight away. If we make 12, if we make this equal to 0, so x squared plus 4x minus 12 equals 0. And then that will factorize. Can you tell what it will factorize to? This will go to x minus 6. Nope. Minus 2 times x plus 6 equals 0. So minus 2 times 6 is minus 12, minus 2 plus 6 is 4. And then the two values for x that we've got are going to be positive 2 or negative 6. Minus 6 or 2. So that one's going to be minus 6 and that one's going to be 2. And job's good 'un. Wonderful. Well done if you followed that. So if you want the x and the y intercepts for a circle, excuse me, then you need to bear in mind that on the x and the y axis, the other coordinate is going to be equal to 0. So you just substitute 0 in for x and y individually, one at a time, solve for each of them, and you'll get all the x and the y intercepts. So for a circle, the standard format for a circle, let's write some of this information down. The standard format for a circle is x minus a squared plus y minus b squared is equal to r squared. That's the standard format for the equation of a circle. If you want the center of the circle, center, I think it's RE, not ER. The center is just coordinates AB. So whatever numbers those are, if this was x plus 4 squared, then it would be minus 4, would be the x coordinate for the center of the circle. So it's the negative of whatever is being added onto x, basically. The radius of the circle is the square root of the number on the end, because the number on the end is r squared. So the radius of the circle would just be r. So it's the square root of whatever number is on the end of that. So if we've got x plus 5 squared plus y minus 10 squared equals 100, then the center would be minus 5, 10, because it was x plus 5 squared. So yeah, let's write that as an example. X plus 5 squared plus y minus 10 squared equals 100. The center, AB, would be the negative of those, so minus 5, 10. The radius would be the square root of that, so 10, because that is r squared. It equals r squared, so the radius r is the square root of that, which is 10. And then the intercepts, oh, excuse me, got a tickle right at the back of my throat. The intercepts, to get the intercepts, well, let's write each one individually. The x-intercepts make y 0. So make y equal to 0 and then solve for x. So for this one, we could make y 0. If y was 0, this would be 0 minus 10 squared, which is 100. So x plus 5 squared plus 100 would equal 100. Therefore, if we take 100 from both sides, x plus 5 squared equals 0. So x would be minus 5. So this one just happens to touch the, it only has one solution for x, so it just kind of touches the x-axis at minus 5. And if you wanted the y-intercept, you would have to make x equal to 0. So this, but all the x's changed to y's, and the y changed to an x. So the y-intercept, y-intercepts would be make x equal to 0 and then solve for y. And jobs are good. That would be it. Okay. Yeah, bit tricky. Can be a bit tricky. But I'd really do just recommend finding some questions on it in a textbook. If you've got any A-level textbooks yet, then have a look for stuff on completing the square and circles on that. But yeah, completing the square, if it's just a few topics that you'll have done in GCSE, if you've done the GCSE or the IGCSE or whatever, pretty much any specification, it's just a few topics where if you've done them but you're not completely sure on them, make sure you know exactly how to do them. You need to know exactly how to complete the square and be really confident with it, and how to make a circle and a graph. It's just some stuff that from the start is good to make sure that you've got a good understanding of, because those are like the foundation, the important foundational stuff to go into the A-level with. That and a hell of a lot of algebraic skills. So we're going to be focusing on that probably for like a few weeks at the start. It's always the first thing that we need to focus on is algebra, just loads of algebra for A-level maths to start with anyway. So yeah, that's pretty good. It's not really been an hour, and I was kind of planning on doing an hour at a time. It's only been 50 minutes, so I feel like I'm cheating people out of maths. But I mean, that's all I really wanted to cover today, so I'm happy with that. So we'll leave it at that. If you're watching this video, I've recorded it, so they'll all be available on YouTube. But obviously, if you hear that, then you've just watched the video, so you've even watched it on anyway. Any future videos should be available on YouTube. I'll put them on YouTube as soon as possible. So if you're watching on YouTube, go like my page to watch them live. It's just Tuition, the maths page. You see that way. That logo in that corner there, Tuition. Just type that in on Facebook and like the page and follow it and then you'll be able to comment as I'm making these videos. If you're watching it on Facebook, type in on YouTube Tuition, look for that thing up there and subscribe. But yeah, that's pretty good. That well done if you followed all of that and you've understood it. Like I say, it is really important, so if you haven't, go revise it, because you do need to know it. Next week, more algebra. I'll see you then. Ta-da then out.